In this video, we are going to go over chapter 10.3, which is operation in Taylor series. Last videos, we were learning what the Taylor series is and use the Taylor polynomial to approximate the function. So the goal of this section is to perform some basic operation on Taylor series. So here are some property. When you have a two Taylor series, you can add them up by term. So constant term, a sub 0, b sub 0, and then the x term, just like algebra, and then x squared term, and then whatever x to the nth power is. So addition is valid. You can also multiply the Taylor series given at 0. You can multiply term by term. So let's say you have a Taylor polynomial and then multiply by some c of xr, then you can use kind of like the distributive property, and each c of x to the r will be added on. Differentiation. You can also differentiate Taylor polynomial, Taylor series. And then you differentiate it by term, the constant term, and then the x term, and then x squared terms, and so on. And last property is integration. You can also integrate Taylor series. If you have a Taylor series, you will integrate term by term. So let's use those four properties and then what we did last week to work on a couple of the exercise. Number 1, find the Taylor series at 0 for f of x equal to 1 over 1 plus x plus e to the x. And find the interval of convergence. Now, I am looking into some properties, and this Taylor series is something that we don't know. But if we look at the function, there's two functions that we know. 1 over 1 plus x and then e to the x, and those are added together. So maybe I can actually separate these into two different functions. And we know term by term. So, recall, so that's what I've been noticed. And if you look at the table given by a PowerPoint in section 10.3, these are some basic Taylor series with the interval of convergence, and we have these two given. This is what we needed, right? 1 over 1 plus x, so that's this one over here, and then e to the x. And we have the Taylor series already written down with the interval of convergence. So very convenient. So I'm going to use this table here. Okay. So we have from table 1 in section 10.3, we are given that 1 over 1 plus x as 1 minus x plus x squared minus rotates, right? All the way up to plus negative 1 to the n, x to the n. And then the interval of convergence is between negative 1 to 1. And we are also given e to the x function, which is 1 plus x, 1 over 2 factorial x squared, plus 1 over n factorial x of n. The interval of convergence is all real. Okay. All right, so your f of x is just combine of these two. Property number 1. I can combine it by adding term by term. So your f of x, which is 1 over 1 plus x plus e to the x. So let's add term by term. The first term will be 1 plus 1. So I'm going to have 2. Second term, let's add the second term. Negative x plus x. So my second one, we are adding term by term. negative x plus x, but they cancel out, right? Negative x plus x, that's a 0. So I'm missing that red term. The third term will be this one, x squared term, right there. So that will be 1 plus, that's 1 right there. That's my coefficient 1 over 2 factorial x squared term. Then let's keep going. I should have a x cubed term, right? X cubed will be just negative x cubed if we follow the pattern. So I'm going to have 1 minus 1 plus 1 over 3 factorial x cubed. Is everybody follow the pattern? All the way up to the nth term will be right over here. This is x to the nth term. So I'm going to have 1 over n factorial plus negative 1 raised to the n, x to the n, dot, dot, dot. Okay, and that's it. That's my Taylor series. And then, there you go. Just adding term by term, because we have already 2 separate ones. And then the interval of convergence is the intersection of the 2 functions, which is they only intersect between negative 1 to 1. So interval of convergence is between negative 1 to 1. Done. It's easy because we have already 2 given Taylor polynomials, so we can use the property to add and subtract. Okay. Let's do number 2, and then I'll leave 3, 4, 5 as try on your own problem. Okay. So again, I do see another adding term. Okay. Here you have this ln, and then you have e to the x. Okay, so let's take a look and see if the table we have here, we do have it, ln 1 minus x, and then e to the negative x. So I'll be using these two and then add term by term. We have ln 1 minus x as negative x minus half x squared minus 1/3 x cubed minus 1 over n x to the n between negative 1 to 1, and e to the negative x is also given as 1 minus x 1 over 2 factorial x squared minus all the way up to negative 1 over n factorial. This will be your nth term. Negative infinity to infinity. All right, let's add coefficient of corresponding power of x. So I don't have any constant term on the ln function, so my constant term is just 1. So my function f of x, which is ln 1 minus x plus e to the negative x, will be 1. And then my constant term for the x term, right over here, negative x plus negative x, I'm having negative 2x. The square term, right? Square term, right over here. So I will have negative half add 1 over 2 factorial x squared. Okay. The third one will be kind of, you can see the pattern, negative 1/3 plus 1/3 factorial. Okay. X cubed. All the way up to, now you have the nth term, which is negative 1 over n the nth term right over here, plus negative 1 to the n over n factorial x to the n. Interval of convergence, they overlap at negative 1 to 1. So the interval of convergence is again negative 1 to 1. Okay, so 3, 4, 5, you can all use a table. So I'll still leave out, I'll still give you the answer. After you use the two Taylor series, you would end up having your f of x end up being looking like this. 5x minus 5x squared plus 5 over 2 factorial x cubed. And then 5 negative 1 to the n factorial x to the n plus 1. And then the radius of a convergence is interval of convergence, I will abbreviate as IOC, will end up being negative infinity to infinity. Try using the chart. Same thing with number 4 and 5. Number 4, try on your own. Your series will end up looking like 3x cubed plus 3x to the 4th, 3x to the 5th, 3xn plus 3. And then interval of convergence is negative 1 to 1. Last one for you to try on your own. F of x ended up being negative 1 plus 2x minus 3x squared, negative 1 raised to the n, x times n x n minus 1, and then the interval of convergence is negative 1 to 1. Okay. All right. Now I like to do 6 and 7 because now this one asks you to take the they give you this extra condition, f of 0 equal 2. And then I want to show you how you can use that to write it out. Okay. All right, so I'll do number 6 and 7, and then you can try number 7 on your own. So let's try number 6. Number 6, also you're given this derivative function. So in order for us to write just f, we need to take antiderivative, right? Because I need to come up with f, and you're given f prime of x. So that's one thing that's a little bit different in number 6. So I like to also go over this. But let's take a look. What do we know from the chart? We know that x cube function, and then we are given e to the negative x. Okay, so I'm going to be using some properties here. This is a basic Taylor series. Then just apply a little bit here. So f prime of x, that's what we are given. X cubed e to the negative x. And then I'm going to pull out x cubed and then just replace this with our table here. 1 minus x plus 1 over 2 factorial x squared minus 1 over 3 factorial x cubed, and so on. This we know. So this part over here that I'm just writing in the parentheses is from table 1. And of course, this e to the negative x function. To the negative x, our interval of convergence is negative infinity to positive infinity. Okay. All right, so I'm going to be distributing this because I need to eventually take antiderivative to come up with f. So my f prime of x will look like x cubed minus x to the fourth, distributing. And then this one will be 1 over 2 factorial x to the fifth, right? You gain each x cube of it, minus 1 over 3 factorial x to the sixth, all the way up to negative 1 to the n over n factorial xn plus 3. Now, let's integrate. So we come up with the f. As soon as you integrate, now you have f of x. So raised power divided by new power. And because it's a definite integral, there's no number in front, I'm just going to use plus c. I can add plus c here, but I don't like having that after dot dot dot, so I'll just put plus c here. That's just considering that I'm adding a c at the end, but I just put it in the front. First term will be x to the fourth divided by 4, so 1 over x to the fourth minus 1 over 5 x to the 5. And then you have this over here. That's a 6, and then 6 times 2 factorial, right? 1 over 6 times 2 factorial x to the 6. And then same thing, 7 x to the 6, right? Raise the power divided by nu, so 3 factorial x to the 7th. You have negative 1 and n plus. Basically, you have adding 4, right? 4 and factorial. X to the n plus 4. Dot, dot, dot. Now, our initial condition is f of 0 equal 2. So if I plug it in f of 0, think about this. You can write this, but when you plug it in 0, this one is just going, I don't have anything here. So f of 0, if I plug it in 0 here, this will be 0. This will be 0 because I'm plugging in 0, 0, 0, 0. Everything will be 0 except you just have a c term surviving. So c is equal to, what is it? 2. So I really have, right? I really have everything repeated here plus 2. So I'm going to do a little bit of a saving time. Copy. Actually, I'll just rewrite it. So my f of x end up being 2 plus just the same term. Because everything will be just 0 out when you plug it in 0. Now, how did I know that n plus 4? That's another question. And then you can look at the pattern. Look at the power, 6 and 2. So 2 plus 4 is 6. 3 plus 7, right? So you see the pattern of n plus 4. That's how I figure it out. Now, from the table, we know that the interval of convergence for the e to the x is a negative infinity to positive infinity. So therefore, my series for f of x of interval of conversion also is negative infinity to positive infinity. Okay? So we just come up with the Taylor polynomial and then we found the interval of convergence. Let's do one more and then I'll leave number 8 as your practice problem. Find the Taylor series. We have a ln plus 5x. Now we have from the chart ln of 1 plus x, not the 5x. So you cannot just plug it in 5 in front. That's not the same. We are just given ln of 5, ln of just 1 plus x. Okay, so we have to do a little bit of algebra work to modify. So one thing that I can write is you can write into two function. Let's say g of x is just 1 over ln 1 plus x. And then f of x is then going to be what? Ln of 1 plus 5x. You can rewrite that as g of 5x, isn't it? Isn't f of x as a 5 of g, but then multiply by 5 here? Look, if you plug it in 5, right? 5x. Then replace x as a 5x ln 1 plus 5x. So that's what it is right there. So your f of x will be g of 5x. Okay? Very simple. Also, this is nice because I can use multiplication rule. So I have a multiplication rule. Okay? So we can use that as well. So let's start writing out. Well, we know that ln of 1 plus x from the table is x minus 1 over half x squared plus 1/3 x cubed. That's table 1 from 10.3. All the way up to negative 1, raise it to the negative n minus 1 over n, x to the n, negative 1 to positive 1. This is f of x, but f of x is 5 times of it, right? So f of x is ln of 5x, which is just 5 times of x. So f of x is g of 5x. So I'm going to be multiplying 5 for each term. So 5x, negative 1/2, 5x, x squared, plus 1/3, 5x, and then x cubed there, all the way up to 5 x negative 1 n minus 1 over n x n. So rewriting, doing some little bit of algebra. So I have 5x minus 1/2 with 5. So 5 over 2 x cubed, x and x squared cubed, plus 5 over 3 x to the 4th. And then this x and then this x I can combine. I have 5 times negative 1 raised to the n minus 1 over n, x to the n plus 1, dot, dot, dot. Since g of x, ln of 1 plus x, the radius of convergence is negative 1 between negative 1 to 5, but we multiplied by, so this right over here, the interval of convergence is between negative 1 to 1, but we are really looking at 5x because that's what we substituted. So we would end up having the radius of a convergence as negative 1 over 5 to 1 over 5. Okay. So f of x, the interval of convergence is negative 1 over 5 to positive 1 over 5. All right, the last one, I'm leaving it out for you, but you end up having the f of x, so you do a little bit of an algebra to modify and then use the table. End up being 1 plus x cubed plus 1 half factorial x to the 6th, 1 over 3 factorial x to the 9th, 1 over n factorial x to the 3n, and interval of convergence end up being negative infinity to positive infinity. So try the similar problem. Okay, that's it. And the next video we'll finish the last section of chapter 10.